Hello guys, in this short video I would like to discuss about what is Young's double slit experiment. In this video we will come across words like maxima, minima, maxima, slit, fringes and this term Young's double slit experiment, as well as an equation, a very valuable equation, x equals lambda capital D over small d. We will understand later, but what is the relationship of this knowledge into what we learned? Have a look. Let's think there are two wave sources. What we learned is, I will give you a question. This is source 1, this is wave source 2. Let's think both of them have same wave. What I mean is wavelength is 4 meters. I asked what happens in point A. Obviously, we learned path difference here is 17 minus 15, 2 meters, or you can say 2 divided by lambda. In this case, 2 divided by 4, half lambda, right? Sorry, lambda divided by 2, sorry, half lambda. So we call this is a destructive place. Now this is a very technical point. Point A is a destructive point, but destruction is said in many different words depending on the wave. Example, in sound wave, destructive places are called silent places. Light waves, we can call it destructive places as dark places, or in general terms you can call destructive places as minima places. Minima means intensity is zero idea. Okay, so all these are meaning no energy, silent, dark, minima, destructive point. All these mean the same thing in different wave context. Now let's go back to find out what is Young's double slit experiment. Double slit experiment. Basically, it is made of two slits. Two slits means small hole is called a slit, and actually there's a one slit here. What we do is we take a wave and we spread it through this one. This is called diffraction. And hold on, let's take here. Let's say we send a wave through this gap, so it diffracts, so it spreads out from here, it spreads out from here, and they interfere, and on the screen they make bright and dark places, or maximas and minimas, like this. Okay, this is what is Young's double slit experiment is. This is called a fringe. These are called slits, I told you before, and this is the screen, right? Now first thing we have to understand is the relationship between, see, this is a bright fringe to bright fringe, or dark, this is a dark place, this is a dark place, dark is the same, and that and the distance from the slits to the screen and the gap between two slits and the wavelength is this one, right? Two wavefronts, these four are interconnected. What is the connection? I will write here. The equation is x equals lambda d over d. I'm sure some of you have seen this equation, but let's think about what each stand for. This is the slits to screen distance, and this is slit separation. This is very small, like 1 millimeter normally. This one is fringe separation. Fringe separation also very small, like 1 or 2 millimeters in real life. I will show you a demonstration next time. This is the wavelength. This is what you need to remember. And one last thing. Now if I go back here, we have to understand this place, central fringe. See, central fringe happens because path difference is 0. Both the waves go exactly same distance. That's why this one is path difference is 1 lambda. This is path difference is 2 lambda. Path difference is 3 lambda. You remember I told you 1, 2, 0, 3, 4. Those are constructive places. And in between, see, this place is dark. So this is a path difference is half lambda place. This one is path difference is 1.5 lambda, like that. One last thing, intensity wise, these are high intensity places, these are low intensity places. So let's go back to check whether we learned what we wanted to learn. Minima is those dark places. Maxima is the bright places. Slits are the small gaps. Fringe are the things you see on the screen. I will show you a demonstration next time. Young's double slit experiment is the setup where two waves go and mix with each other and make an interference pattern. And the equation is this. I'm sure you are not very clear about this equation. Let's put a number. Let's think the two slits are 1 millimeter apart. This is 2 meters apart, and the wavelength we use is 540 nanometer. Okay, so let me, 540 is like blue color, let me take green color. Okay, so two waves go from here, the wavelength and this wavelength is the same, and they interfere and they make, hold on, bright and dark and bright. In between you can see dark, this. And I ask how much is x, either from dark to dark or bright to bright. You can adjust, so they are the same. So the how to do this question, x equals lambda d over d. Lambda is 540, must be in meters. Nano means 10 to the power of minus 9. D is 2 meters. The gap between two slits are 1 millimeter. That's not good. It has to be, must be in meters. Okay. So if you do this calculation, you will get 1.08, all right, minus 6, 10 to the power of minus 4 meters, or 1.08, sorry, 0.108 millimeter, or I may even write 0.11 millimeter looking at the numbers, rounding up to two significant figures. So I hope we understand this one. Now what you have to do is try all these questions. I found those questions about Young's double slit experiment. They focus on this equation, and do this and see you in the class next time. Okay, have a